Welcome to the deep dive. Today we're tackling one of those just incredibly frustrating physical barriers you run into in tech.
Oh,
I mean,
yeah.
the agonizingly short reach of a standard USB cable. So we're going to take a look at the PureLink USB2-E70 extender to see how it sort of cheats physics.
It's a classic problem, right? You've got a peripheral, it needs that USB 2.0 speed, the 480 megabits, and then boom, you hit that hard 5-meter
A
limit.
16-foot wall.
Exactly. And you need to get that signal across a room or maybe even to another floor without spending a fortune on fiber.
Right. And this device, the USB2E70, it does it by using something that's, well, it's everywhere, standard CT5E or CT6 network cabling.
Yeah.
But USB is a pretty sensitive, high-speed signal. So how does this actually work? What's the trick to pushing it over, generic network wire?
Well, the key here is that it's doing an active translation. It's not just a simple amplifier.
Yeah.
It's actually converting the USB protocol into a format that works well over the balanced twisted pair wiring inside a CT cable.
So it's protecting the data.
It's protecting the data integrity. That's what lets the signal travel so much further than the original USB standard ever intended.
Okay, so let's get into the functionality. They say it's plug and play, and one of the big features is that the receiver end is basically a mini hub.
That's right. It lets you extend up to 4 USB devices at the same time. You get 4 Type A ports on the receiving end.
All running back to a single port on the transmitter side on the PC.
Exactly.
Okay, now the part that I think is fascinating, the distance breakdown. Because the cable you choose makes a huge difference here.
It makes all the difference. So if you need that full USB 2.0 speed, that 480 megabits per second, you can get 50 meters over CT5E.
Which is already, what, more than 160 feet? That's a huge jump.
It is. But if you use a quality CT6 cable, you can push that all the way out to 70 meters.
70 meters, that's almost 230 feet.
Yeah, it's a massive extension.
But there's a trade-off, right? Between speed and how far you can push it.
There is, and it's a really clear illustration of physics. If you don't need all that speed, if you can drop down to the much slower USB 1.1 standard.
Like for a keyboard or a mouse.
Perfect example. For something running at 12 megabits, you can extend that signal up to 100 meters.
Wow, 100 meters, over 300 feet.
It just shows you the toll that high-frequency data takes on copper wire.
So installation, is it complex? Do you need drivers?
Not at all. It's all about the physical connections. You link the transmitter, the TX unit, to the receiver, the RX unit, with your C cable, and then you just apply power to the transmitter side. That's it.
And for people installing this professionally, I guess reliability is key.
Absolutely. And this thing is rated with an MTBF that's mean time between failures of 50,000 hours. It also has a 3-year warranty, so it's built to last in a professional setup.
So what does this actually mean for you, the listener, who might be setting up, I don't know, a remote kiosk or a workstation?
It means you can put your important peripherals, like a touch display or a high-def camera or some specialized instrument, in a completely different room, reliably.
And you can do it just by using the cheap network cable that's probably already in your walls.
Exactly. And if something does go wrong, you're not guessing.
Ah, the diagnostic lights.
Yep. You get instant visual feedback. There are indicators for power, for data transfer, and then no link or no power tell you immediately if the cable's bad or if something's just unplugged. It takes the guesswork out of it.
So this deep dive really shows how some smart engineering can completely bypass the physical limits of a protocol like USB.
It really does. By just translating that signal, you turn this short-range headache into a really robust long-distance tool.
It's a powerful idea.
It is. And the broader takeaway here, the thing for you to think about, is the power of using this common infrastructure, like key techs.
If you can do it for USB.
Right. If you can solve the USB problem with it, what other specialized standards could benefit from the same idea? Things like high-fidelity audio or industrial sensors.
So what other common cables could be the key to unlocking these niche short-range protocols? That's a great thought to end on.